Okay, we're going to need an idea about even and odd functions that you have seen in college algebra. Let's talk about that. So I'll go through this real quickly. You really can't understand even and odd functions without knowing a graph. So I'm sure hopefully you've seen this. Do you remember x squared is an even function? And what an even function is that if you reflected it over the y-axis, you get the exact same function. Do you see if I flip this over here, I get the same thing. And here's what it means. Here's how you test it. So we're going to say f of x equals x squared. You test this because if you put negative x in, so in other words, if you were on the back side of the equation, on the lower end of the number line, you're going to get the exact same thing that you would have on the positive side. So here's what I mean. So if you put in negative x instead of x, square it, do you see if I square this, I get right back to x squared? So what it's saying is on the right side of the number line and on this left side, the negative x's, I get the same value of y in either case. In other words, it's symmetrical if you flip it. Now, we're talking about the trig identities here, and we haven't even seen these functions yet, but so it's a little bit premature here, but here's what we've got. This is the cosine function, graphed terribly, but this is the function. And can you see that if you were to flip this over the x-axis, you would, theoretically, if my picture were better, you would have exactly the same thing. So in other words, if you have cosine being treated as a function, you put in negative t, you're going to get right back to where you were before, which is what is easier to see right here. If you put a negative x, you get right back to square. This is an even function. Well, cosine turns out to be an even function as well. So in other words, anytime you put the negative version of t in there, you're just going to get the exact same thing that you got with the cosine of t. So this is going to be a real helpful tool. Now sine, the graph starts here and goes up and down. So and this is an odd function. Now let me remind you, I'm running out of space here, but let me remind you what an odd function is. So x to the third is an odd function. And what happens with an odd function is, if you put in negative x into this, you're going to get, you see you'd be multiplying three negatives times each other. You're going to get negative of the original thing that you had. So in other words, what it means is, so here I'd be putting in x, I get out a y. If I put in negative x, I'm now back over here, and I get the negative value of y. It puts me down here. Now, if that doesn't make sense, here's what happens with an odd function. You can flip it over the x-axis, and then you flip, or over the y, sorry, flip it over the y, and then flip it down over the x, and then you get back to the same thing you had. It's called symmetry with respect to the origin. So you flip it over y, flip it back down over x, and then you're back to where you started. Now, you don't need to know all of this at this point, but these functions, cosine, oh yeah, so I wondered what they were doing. Okay, cosine and sine. So sine, if you put in negative t, you get the negative version of what you originally had. That's just what odd functions do. All of them, that's what they do. So cosine is even, sine is odd. Evens get you right back to where you started. Odd gets you the negative version of what you started with. Now, the rest of this can just be deciphered from the logic of these two things. Okay, well, secant is based on cosine, so if cosine is even, secant's going to have to be even. And cosecant is based on sine, so if sine is odd, cosecant is going to be odd. Now, think about tangent and cotangent. If tangent is sine over cosine, well, the cosine is getting you right back to where you started. It's not changing anything. But the sine would be odd. So do you see what I mean here? So if I had sine over cosine and put in negative t into both of these, this one turns out to be negative sine of t because it's odd, and cosine doesn't do anything. It goes right back to being just cosine of t. So what is all of this? I get negative tangent. So basically what I'm saying is cosine just knocks itself out, doesn't do anything. But if you put negative into tangent or cotangent, from the same logic, it turns out they're odd. Okay, I hope that made sense. But what we're going to do here is we're going to use that principle to say, okay, well, they told us the secant of t is 2. So what would happen if we put in negative t? Okay, well, let's think this through. Well, secant is based on cosine. So cosine is even, and it doesn't do anything at all. It goes right back to where we started. So secant of negative t must also go right back to where we started. Okay, so let's think about cotangent here. So cotangent of t, I guess I should do this. The original one gets us radical 3. Well, cotangent is cosine over sine. So if we put negative t in for cosine, negative t in for sine, where do we get? Cosine doesn't do anything, just goes right back to where it was before. So that's cosine. Sine becomes negative sine because it's odd. So in other words, here's what we see. We have the negative of what we started with. In other words, cotangent's an odd function. So if you started with the square root of 3, what's the cotangent of negative t? It's going to be negative square root of 3. All right, now what's going to happen next is they're going to use these fundamental identities. These are the definitions that we've been using for all of these trig functions to try to solve some basic questions. I actually was already doing this. This is a total repeat of the way I was doing it when I showed you in the last video how we would use the unit circle to find sine and cosine, and then use the definitions to find all the remaining functions. So this is identical to what we were already doing. But let's walk through it here, and then we've got a little bit more new material. Okay, so here's what they're saying. They're giving us the value of sine and cosine of 45. We know that. Now, if we want the tangent of 45, we're just going to put them over top of each other. That's exactly what I did in the last video. If sine's 45, it's this. Cosine's 45, it's this. Square root of 2 over 2 divided by itself is just 1. Now, secant here. Okay, so they gave us the sine and the cosine. We've got 5 pi over 6. Remember here, the reference angle would be pi over 6. 6 into 180 is 30. So this is a 30-degree reference angle. And it's in quadrant 2, if you could picture that. So 6 pi over 6 would be all halfway around. So we're a little less than halfway around. So I've got 5 pi over 6, or pi over 6 my reference angle. I'm in quadrant 2. Well, in quadrant 2, x's are negative. So that's how we got these. Now, secant is based only on cosine. So I just put the value of cosine in here. Now, this is a reciprocal. I keep, change, flip, turn it upside down, however you want to think of it. And I get to this. Yeah, I'm sorry. I'm trying to see what they're doing here because I don't understand. Okay, it would just flip this upside down. I don't know what they're doing. It would flip this upside down, rationalize the denominator, and we get to there. Okay, now let's try this. So you could do both sine and cosine, but cosecant is based on sine. So what we need is the sine of 7 pi over 6, and that information will help us do cosecant. Okay, well, think about where we are here. 6 pi over 6 would be halfway around. So we're a little past halfway around. So we're in quadrant 3. So what's my reference angle? My reference angle is the distance from 7 pi over 6 back to 6 pi over 6. Can you see that's pi over 6? Okay, so pi over 6, 6 into 180, this is a 30 degree. So the sine of a 30. Okay, so remember how this went. Cosine, sine on the unit circle. 30 is the very first one, so cosine goes radical 3 over 2. So sine goes the square root of 1 over 2. So you could use your chart if you want to. But so what I'm getting at here, just thinking it through, is that the sine of pi over 6 is 1/2. Now that's the reference angle, but I'm not in the first quadrant. I am in the third quadrant. And in the third quadrant, sine is y, so y is negative, so negative 1/2. Okay, so sine of 7 pi over 6 is negative 1/2. Okay, now let's do, but we don't want sine, we want cosecant. And cosecant is 1 over sine. So I've got 1 over negative 1/2. Flip that upside down. I've got negative 2. Okay, now this is the a little hint toward the part of the course. I like it a lot, these little puzzles, but you may hate it. It's a more challenging part, but this is like basically just getting our feet wet to the idea of identities, which we're going to take something and twist it around to see if we can turn it into something entirely different just by the logic of our rules of our definitions. So if none of that makes sense, here's what I mean. We're going to see if we can simplify secant over tangent. So let's just put in the definitions of secant and the definitions of tangent, which they've done for us right here. So secant's 1 over cosine, tangent sine over cosine. So I keep change flip, keep the top, change it to multiplication, flip it upside down. Well, aren't these the same thing? So they can go. So I have 1 over sine of t. Okay, well 1 over sine t we know is cosecant. So it turned out that if we use the definitions of secant and tangent, we can show that turns out to be cosecant. Okay, let's play the game again. So tangent is sine over cosine. Now you really should be showing the t, but I'm lazy. I'm just going to do this. Okay. So here's what we got. You see how simple this is? I can cancel the cosines, and I just get sine. So I should put the t now that I'm done here. So this simplifies down to be sine. So real basic, just using those definitions to try to see what they can turn into. Yeah, and I wish I had a few more of those, but I think the ones in this section will start off pretty basic. So, okay, I hope that makes sense. A lot of that we've already done, and then we just have the basic idea of using those definitions, which you should have down by now, I think, to try to turn some trig functions into something else called identities.